Hello and welcome. My name is Jonathan Batselos, and me and my team recently completed a report detailing the cyber operations and risk management of the United States federal government. This is a briefing that will go over the main points of that presentation. The purpose of this briefing is to evaluate software assurance needs and expectations, and also to notify parties about different methodologies available for its development. This briefing will help the organization achieve defense objectives of mitigating cybersecurity risk and having good knowledge of procedures to avoid and/or reduce attacks. First thing we'll get into is software assurance. Software assurance reassures that vulnerabilities are reduced or eliminated by either the design of the software itself, and also while you're designing it, to make sure that vulnerabilities aren't accidentally inserted into the software during its life cycle. Some examples of software assurance are trying to design the software to reduce the potential exposure or release of personally identified information during disaster recovery, constant sustaining of inter-office connectivity and access to data, and also to constrain cost while maintaining this design schedule. So in order to achieve software assurance, it's important that when creating software, the software development lifecycle is followed. Software development lifecycle has 7 phases, the first of which is the planning phase. And this is a project management step where you need to lay out how long is it going, each step is going to take, and what are the costs going to be. Next step is to flesh out the requirements of the software. This is basically what it needs to do. So to give you a point of how to design in the future, you just gotta look at the bare minimum requirements of it. Next we have design and prototype. This is where the first initial steps of actually creating the software are done. It's to get a good feel for the next step, which is software development, where the software is actually created. After that, we have testing, which is when the software is created. It needs to be tested to make sure it meets the requirements. And they can go back between step 4, software development, and step 5, if the requirements aren't met, which would be found out by testing. After software is tested, it is then deployed to what it needs to be deployed to, whether to the networks or to the devices which it needs to be deployed to. That's when it can actually start being used by the people who need to use it. And as it's being used, it's important to have the step 7, which is the operations and maintenance of it, to just make sure software continues to work when other things such as hardware or operating systems are upgraded, that the software still works in that regard. The next topic that we covered in this presentation are supply chain risks. Supply chain risk management is a process of taking strategic steps to identify, assess, and mitigate supply chain risks. Supply chain risks are vulnerabilities that happen throughout any stage of the supply chain. It's different for any department depending on what they produce or what they're supposed to do. Some examples of supply chain risks that organizations need to manage are reputation risk. It is a possibility that a supplier might engage in activity that negatively affects the brand's perception. Financial risk is when a business enters a scenario that threatens their financial health. There's man-made risk, which is the possibility that a supplier will encounter a business scenario that threatens their financial health, and this comes from a person within the company, usually by not doing their job correctly. Natural disaster risk is if a hurricane or earthquake happens, it could negatively impact the infrastructure of the business. Cyber risk is the possibility that the business is harmed by the use of technology, either internally or externally. And geopolitical risk is the possibility that the supply chain is disrupted by global politic events. Next, we went into software vulnerabilities. The risk associated with software vulnerability depends on 3 different factors. First, existence, probably the most important, whether a vulnerability actually exists within the software. And then access, which is the possibility that the hacker might gain access to this vulnerability. And the third one is exploitation, which is the capability of the hacker to take advantage of that vulnerability via tools or certain techniques. Then we're going to list some common software vulnerabilities. First one we'll get into is SQL injection, and this is when the attacker injects malicious code into a system through authorized input ways, just doing it incorrectly or correctly if in their eyes. OS command injection, which happens when software integrates user manageable data in a command, which is handled under the shell command interpreter. Then we have buffer overflow, which occurs when more data is put into a fixed length buffer than the buffer can handle. And then we have uncontrolled format string, which involves accepting unchecked and unauthorized user input as a format string to execute a function. And last we have integer overflow, which is similar to buffer overflow, but deals with numbers and calculating them. Other than the software development lifecycle that we went into before, there are also other models that do work to develop software as well. This one we have here is the waterfall model, and as you can see, it's very similar to the software development lifecycle that we went into before. But as you can see, what's different is it's not just a linear design. You can go down the line, but you might need to reassess and then go back to a previous step. Like we said before with testing, during testing you find out that there's a bug or an error, you need to go back to develop more. Same can be said throughout the line that you have a finished project, but you realize it needs to meet a different requirement, so you need to go all the way back to the requirement analysis, and you got to start from that point again. And this is another software development methodology. It's called Agile Software Development. It's a little bit different from the first couple, but as you can see, it's a circle. So after you get to the deployment phase, which is in this model, the last one, you need to go back to the beginning and reassess what you did and see if you can make any improvements on it. And next we have another software development methodology. This one's called Scrum Development. The reasons why people use it are because time and money are judiciously and effectively utilized. Projects are managed effectively by dividing them into sprints. Daily Scrum meetings help clients stay up to date with the projects and the team stays focused. This can be used in addition to and with Agile methodology, and it's quite flexible. And it works really well when you have a small team of people doing it. It tends to not work as well when you have a large team because it's hard to communicate between all members. And it's only really useful when you have experienced and dedicated team members, and daily meetings and updates are sometimes hard to keep track of. And the last one that we have here is rapid application development. The reasons people use this are because task becomes easy and achievable by modularizing project, putting it into small little things that people need to do. The functional model of the project can be reviewed in an early stage, and the user remains in the loop while the development is happening and is able to provide feedback during that period. The reasons why it might not work in some scenarios is that it requires highly skilled designers and developments with a specialty in the application area. And it works best when you can split the project into small chunks, which you can assign certain people to do. And it is also highly expensive to do as well, so it's not recommended for people with small budgets. At the conclusion of the report, our team put forth some recommendations that we feel will help build secure software and to have an understanding of software vulnerabilities while you're creating the software. First step is to regularly update the software. This is the last step of the software development lifecycle, where operations and maintenance, sometimes you got to go back to the beginning if things such as operating systems change or requirements change or something to that nature. Next is to implement the use of anti-ransomware to try to prevent against those attacks. Next, we have build a strong firewall to try to keep unwanted traffic off of the network. Then we have review and update security policies. This is important that periodically you go back and review the security policies that you have in place because they might become outdated at some point and you need to revisit them, maybe redo them, or maybe just tweak them slightly so it helps in the future. Next, we have install security tools to devices. This can mainly be encryption level things such as BitLocker or some form of multi-factor authentication. And then strictly monitor the network. It's important to have either IDSs, intrusion detection systems, or have professionals continuously monitor the network so you pick up on any malicious things happening before they have a negative impact. Next, we have implement SDLC measures using software development methodology. We went into a couple of those before, but it's very important to have a set plan going into software development. We have secure patch management policy. When you patch software or operating systems or anything at all, it's very important that those patches are secure because they are very widespread and they're dealing with the root of the systems that they get into. Next, we have specifying the primary contacts for each vendor. It's very important to have great communication within the department and also outside of the departments for different projects because this prevents against social engineering attacks where a malicious actor will come in and act like an authorized vendor to gain access that they shouldn't get otherwise. And finally, train employees about vulnerabilities. This is important because the employees are the ones actually using the software, so they should be informed on vulnerabilities that could occur so they can report back to you and so they don't use the software in a way that produces vulnerabilities. All right, and that is the conclusion of this presentation. You can see our references are on the screen. If you have any questions, please let us know, and thank you for your time.